We've been learning a lot about similar polygons and specifically similar triangles. So if we have some triangles like this here, let's say we've got some right triangles. Let's say we know this is 30 degrees. Okay, then we know right now by the angle-angle similarity, these two triangles must be similar. Since they're similar, their sides have to be proportional. So if we know that this has a side of like 3, this will have a side length of 6 for that hypotenuse there. And maybe this is 4, so the ratio has to be the same. So since these are both similar, if I want to find this side, it has to be in the same relationship as these two sides. So what's the relationship between these two sides, this hypotenuse and this leg? Well, that's twice as big. So if I take this 4 times 2, I can figure out that this hypotenuse needs to be 8. So those relationships are predictable, we can say. So whenever we have a 30-degree angle, that's actually going to be true. So we have some names for these ratios that we're going to use. Altogether, this is what we call trigonometry. So this is the basics or the basis of trigonometry. So let's define some things here first of all. We've been talking a little bit about some of these here. And so if we have a right triangle, we have 3 sides, of course, because it's a triangle. We've got a right angle. And so this side that doesn't make the right angle, notice these two sides make the right angle. This other one is called the hypotenuse. So in a right triangle, we give the name hypotenuse to the side opposite of the right angle. So this word opposite is an important. You can think of it like this. If you're standing over here at this angle here, at the angle C, if you wanted to walk to the opposite side, well, that is this side over here. So starting at this point, the opposite of this angle is this side, which is the hypotenuse. We also have some special names for the two legs. So again, we have a hypotenuse, and then these two sides that make the right angle are called legs. And those legs are useful to us. All right, and so they have a special relationship depending on which angle you're looking at here. So let's say we're standing over here at angle A. So here's angle A, and we're standing on this side, maybe on this side of a big field or something like that. And so in this diagram, when we look at this, AC, this side AC, is connected to the point we're standing on. It's connected. And so we say that that is adjacent. Adjacent means next to or connected to angle A. And if you're standing over here, then this side BC, this is all the way on the other side of the triangle. So that is BC there is the side that's opposite to angle A. Okay? So there is a leg, and this leg here is opposite. This leg is adjacent. Now, if you're standing at angle B, so let's say, all right, so this is Alice over here. So Alice is standing over here. All right, we should give Alice some pretty hair. There you go. All right, there's Alice. She's got some pretty hair. And over here we got Billy. Billy's standing at B over here. All right, there's Billy. All right, and he's just a little guy. So Billy's standing over here at angle B. So if you're standing at B, which one of these two legs is connected to Billy here? Well, BC is. Well, now BC is adjacent. Which leg is on the other side? Well, this AC is all the way on the other side of the triangle. So if from angle B, then this side AC is opposite. And this side BC is adjacent. Okay? So we need to be able to recognize these kind of quickly here. So the hypotenuse is always the longest side, opposite the right angle. And the adjacent is the one that is connected, the leg that is connected to the angle. So we'll say that's the connected to the angle. The opposite side is not connected, or the opposite leg, we should say. Let me just put that in parentheses. This is not connected to angle A. All right? So this is adjacent to angle A. This is opposite. Well, we can come up with some ratios that are important. These are what we call our trigonometric ratios, or our trigonometry ratios. And we have 3 trigonometry ratios. So if we have our right triangle like we do up here, if we look at the leg that's opposite of an angle, like angle A, and we compare that to the hypotenuse, that's called the sine. And we have an abbreviation for that. We're going to abbreviate sine, S-I-N-E. No, I didn't spell it wrong. We're going to abbreviate that as S-I-N because we want to save a whole letter there, okay? So S-I-N is an abbreviation for sine. We read it as sine. So here we have the sine of angle A. So this is the sine of angle A, and we'll abbreviate that as the opposite over the hypotenuse. So we'll see that abbreviation often. If we take the adjacent leg over the hypotenuse, that is the cosine. So we abbreviate that cos of an angle. Cosine of angle A is the adjacent over the hypotenuse. And last but not least is what we call the tangent. So the tangent is the ratio of the opposite leg over the adjacent leg. We abbreviate it tan, T-A-N, of angle A, and that is the opposite over the adjacent. All right? So these are our 3 very special ratios that we're going to be using: sine, cosine, and tangent. The measure of the acute reference angle, this A or B in the right triangle, determines the values of these ratios, because as the angle changes, the sides change in length. All right? As the angle changes, the sides lengths change. All right? And that gives us a different sine, cosine, or tangent. All right? Great. Well, let's kind of look at a little bit into how this works. So we can start with a couple triangles that we know a little bit about. If we have this triangle here, all right, this is what we call a 45, 45, 90 triangle, because the angles are 45, 45, and 90. Well, this is half of a square. Okay, so if we double it up, we got a square. And what do you know about the sides of a square? Well, they're always the same, right? And so if this side is 1, then this other length over here has to be 1, right? So if we have 2 sides of length 1, let's say we want to find this length right here, well, we can use the Pythagorean theorem. 1 squared plus 1 squared equals c squared. This is 1 plus 1. This is 2. And we square root. And we get the square root of 2, which is the exact answer. So this length is the square root of 2. All right. So let's find the sine, cosine, and tangent of that. All right. So the sine, so let's say we're standing over here. Here you are. Here's your angle A. And we want to find the sine. Now we got to remember this here. So the sine, we just were introduced it to, the sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. The tangent of an angle is opposite over adjacent. So if we're standing here and we want the sine, that's opposite over the hypotenuse, all right? So this is the opposite here. This is the adjacent leg, and this is the hypotenuse. So opposite over hypotenuse for this angle here is 1 over the square root of 2. Cosine is the adjacent over the hypotenuse, so it's adjacent is also 1 over the square root of 2. And the tangent is opposite over adjacent here. So the opposite is 1, the adjacent is 1. So the tangent is 1 over 1, which is 1. And that's going to be a useful relationship. Well, what about this other one? It's 30 and 60. All right, how do we find sine and cosine of those? Well, this is half of something else. It's not half of a square. I guess you could make it half of a rectangle, but we want to make it half of an equilateral triangle. So if we have an equilateral triangle, in an equilateral triangle, all sides are the same and all angles are the same. And so if that's 60, this is 60, and this is 60 degrees up top in this whole triangle here. So since that's all sides are the same, if this side is 1, then this whole thing here would be 2. And this is an equilateral triangle that I just drew. So this would have to be 2 over here, the hypotenuse. Okay, so we got the hypotenuse there. And, well, what about this other side? We'll call this x for a moment. Well, we've got the Pythagorean theorem. 1 squared plus x squared equals 2 squared. Let's try that out. Okay. Pythagorean theorem to the rescue. This is 1 squared is 1. 2 times 2 is 4. Solve for x. Subtract the 1. And square root. If we square root both sides, we get x equals the square root of 3. Okay, so this length right here is the square root of 3. So we now have all the sides of this triangle here. So we can find some sine, cosines, and tangent. Let's give it a try. Using those definitions up above in red, all right? So now, if we want to look at the 60-degree angle, let's imagine that we're standing over here. Can I bring my little guy? There we go, all right? So now I'm standing at the 60-degree angle. So since we're standing at the 60-degree angle, this is opposite. This is adjacent leg because it's connected to that angle we're standing at. And so let's find our fractions. Sine is opposite over hypotenuse. So we look at the sides, and we say the opposite is the square root of 3, and the hypotenuse is 2. There you go. The cosine is adjacent over hypotenuse. So the cosine of 60 is the adjacent 80 over the, the adjacent 1 over the opposite 2, 1/2. And the tangent is opposite over adjacent. So from here, we got opposite of the square root of 3, adjacent is 1. So we have the square root of 3 over 1, which is just the square root of 3. So there's the sine, cosine, and tangent of 60 degrees. Now your calculator, which we'll see soon, if you go to your calculator and we punch in the sine of 60 degrees, you should get the same number or the decimal version of this. Okay. Well, what if we're standing in a different place here? So what if we get kind of tired of standing down there? We go up to this part of the triangle here. Now, with that, we're going to, as the side that we're looking at, it'll change the opposite and adjacent. So now we're standing over here at angle 30-degree angle here. So the opposite is 1 and the adjacent is the square root of 3. So let's use that to come up with a sine, cosine, and tangent of 30. So sine is opposite over hypotenuse. So 1 over 2. Cosine of 30 degrees here is the adjacent over the hypotenuse. So that's the square root of 3 over 2. And tangent is opposite over adjacent. So the opposite is 1. The adjacent is the square root of 3. So we're going to write 1 over the square root of 3. And what do you notice about all of those fractions here? Well, notice that this is square root of 3 over 2. The sine of 60 and the cosine of 30 are the same. And the sine of 30 is the same as the cosine of 60. Also, notice what happened to the tangents. They flipped. All right, so lots going on here. But that's the idea. So that's how we define sine, cosine, and tangent and how we can find it. Well, let's give it a try down here on this check for understanding as an example. And so if you want to pause it, you can give that a try there. Let's see. We want the sine. Sine is opposite over the hypotenuse. So we want the sine of A. So we're standing over here. That's our reference angle. There you are. There someone is. we're standing at A, and so sine is opposite over the hypotenuse. So this opposite is all the way on the other side. Hypotenuse is the longest side, and this would be adjacent. So the sine is the opposite length, which is 5, over the hypotenuse, which is 13. Cosine is the adjacent leg here, which is 12, over the hypotenuse, which is 13. The hypotenuse is always the longest side, remember. Tangent is opposite over adjacent. So tangent is the opposite, which is 5, the adjacent, which is 12. So that's 5/12. 5 divided by 12. There you have it. Okay. Well, what if we want to find a missing angle measure or missing side measure? How can we do that? Well, let's use the tools we have right now. We know the angles add up to 180. So we know 90 plus A plus 31. Let me make that an A that looks like an A. There we go. That has to equal 180 degrees because the angles in a triangle add up to 180. Now, let's do this. You could add those, but I'm going to go ahead and subtract 90 because I want to show you something. Notice this, A plus 31 equals 90. So this is kind of showing us that when you take the two acute angles in a right triangle, so if it's a right triangle, these two have to add to 90. So in a situation like this, we can jump straight down to here. You don't have to write this long one out. Okay? We know they add up to 180, and the small ones add up to 90. So if we subtract 31 from both sides, we get our answer. And let's see, A equals 59 degrees. Well, what about the missing side there? Well, we have trigonometry, but this is just review using the Pythagorean theorem, right? Because we got two sides of a right triangle. We know that A squared plus B squared equals C squared. And in the C has to go the hypotenuse, which the hypotenuse is that N. So 3 squared plus 5 squared equals N squared. So 9 plus 25 equals C squared. Or N squared, sorry about that. Let's use the same variables. Let's keep it N. And this is 34 equals N squared. If we square root that, then we get the square root of 34 equals N. All right? Square root of 34 equals N. That's the idea. So we got our missing sides and our missing angles. All right? So let's go to one more. You can pause it and try it yourself if you like there. We know the angles add up to 180. Or if you want, the two small angles, because it's a right triangle here, so the two acute angles have to add up to 90, because they're 180 total. Take 90 away. There's 90 degrees between these two. Make sense? Cool. So let's subtract 76 from both sides. A equals 14 degrees. And so we're done there. That's easy enough. And how about a little Pythagorean theorem here? So we've got, remember, we've got to take the legs squared. So that is 4 squared plus N squared equals 17 squared. And so we square this up. And 17 squared is 289. So let's make that 289. All right, let's subtract 16. N squared equals 2, what do we got? 74. And we're going to square root that. Actually, 273, of course. All right. Well, that's not an exact number, so we'll just leave it as the square 273. Okay, it's not a perfect square. Okay, if you want to get decimal, you can go to your calculator and get that decimal. So there you have it. All right, well, there's our tools so far, Pythagorean theorem and the angles adding up to 180. And that will be the basics, or the basis of trigonometry, which we'll use sine, cosine, and tangent. Turns out to be a very useful tool. So, all right, thanks for joining us for this introduction to trigonometry. See you soon.